Hello, everyone, and welcome to day 3 of Winter Workshop 2022. Today, we're going to be going over fuzzing, web fuzzing, and with that Yao will be taking over that. Afterwards, we'll be going into password cracking and brute forcing. These topics are very interrelated, and we figured it'd be better to present both of them at the same time. It's going to be a little bit of a repetition for both since they are, again, essentially the same topic, but they are still nonetheless useful for everyone out there. But again, one thing I would like to reiterate too is don't use these against any sort of site, any password place, whatever. You will be flagged, you will be banned, you will be blacklisted. So just keep that in mind if you thinking about like trying to brute force your friend's Facebook account, if you have Facebook, for probably Twitter now. I'm not sure. I don't have social media. Whatever. Without further ado, Yao, go ahead and take it away with your fuzzing workshop.
Thank you. Can you enable the screen share?
There you go.
So hello everyone. I'll be presenting web fuzzing today. So we'll be going over what is fuzzing, and since we're doing web stuff, we'll also cover the basic of hypertext transfer protocol. And next we'll go into the detail of how fuzzing works and its process. And then we will go over cyclists, which is a word list that was mentioned in previous workshops. And lastly, we will go into the demos. First, how to install the tools and the word list. We will be setting up our Docker containers, and then we'll be going over the techniques of how to fuzz the web server. All right. Yeah. So first, what is fuzzing, right? So in software development, specifically software testing, fuzzing is used to find software bugs and vulnerability by feeding random, invalid, and unexpected data. So that could be like a random string of characters or ASCII codes. And in specific hacking, we will try to enumerate web services and find new pages or hidden resources. And we'll go over how to do that. And here we have a couple of examples. On the left is a punching card machine. And in the old times, they would feed random punching cards, like random holes, and they'd feed it in the program to see if it can cause like unexpected errors or crashes to the program. On the right, we have a terminal. This is the tools we'll be using today. So do you guys have any questions on what is fuzzing? If not, I can move on to the next portion. So what is HTTP? So to understand how web servers communicate with your browser, first to understand the GET request. It's a request to retrieve resources from the web server, and it's what we'll be using to fuzz, right? We're trying to get maybe hidden resources, or it's not visible on the web. So here we have a method, the GET method, and this is the URL. And we can ignore these headers, but they're kind of self-explanatory. We have the host that we're trying to send the GET request to, and we also have user agent, like what type of browser or operating system you're using. Do you guys have any questions on this? So let's see an example, right? So let's say you try to go to google.com, the image searching website. So when you hit enter on this search bar, it will actually send this request. HTTPS use the same request. Is that what you're asking? But it's more a secure version of communication, right? So data will be encrypted in this case. So we'll be sending to the host google.com, and we're using Google Chrome, and there's more header, but we're not going to cover that. And once we send a request, we will expect a response, right? So this is how the server will respond to us, right? So if you look at the first line of the response, they will give us a code, right? So 200 means okay, and 44 means not found. And another common one is 403, which is forbidden, which means you don't have permission to view the resource. That's why it will give you a couple of headers, right? Like the is Apache content of the page. So do you guys have any questions on HTTP? Or we can go into the process of fuzzing. So how does fuzzing actually works? So this is a diagram of our fuzzing applications, right? At first, it will need a word list, right? It could be a list of URLs that we're trying to get to that may not be visible on the website. And what we do is we will ask the fuzzing application to send a bunch of get requests, right? And to the web server. And they can either respond with 200, which means there is a website, a web page, or there's 404, which is not found. And we can have do a more detailed of a test run. So here we have a word list, right? A bunch of HTML files. We're not sure if these files exist on the web server, so we'll try to fuzz it, right? So we will run some sort of command to fuzz it. We'll fuzz example.com as an example, right? So the fuzzing application will first read the word list, right? So it goes first line, and it will send this request, right? Index.html. Okay, so it responds okay, right? And the terminal will output it's there, right? So to show us that resources exist, this web page exists. So it goes down the word list again. And again, it sends about HTML. This time it's also okay. So it tells us it's there. Next is hello. It sends the same request, but change the URL here. And unfortunately, it's not found, so it won't show us anything up here. And move to contact, right? And again, it's okay, so it will gonna show us out in the output here. And lastly, we have home. And unfortunately, it's not found. So this is our final output, right? And the output will change with the word list, right? So maybe there's more stuff down here that we haven't covered, but this is just an example run. Do you guys have any questions on this? Now we can talk about word lists, right? So what is cyclists? So Cyclists is a repository of word lists, right? So here we have two word lists that's common to Fuzz websites. So we have a common TXT and we have a big TXT. You can see that the common is a bit more smaller than the big one, but looking at the number of words here. There's also username and password lists, right? That will be used to maybe brute force password, brute force usernames, right? Checklist is on GitHub. You don't really necessarily to create your own word list, but sometimes you would have to, right? I think Ryan gave an example of he has to create a football word list in order to crack to brute force some password. But in this case, for this workshop, they will be provided for you on GitHub. So we have username and password. So do you guys have any questions before we go into installing the tools we'll be needing for the demo?
For the word list that you guys create, like going Ryan, you're saying creates on his own. Does he just like make up a gigantic list like the one we were just looking at, like by himself? Or does he get, does he go anywhere else for resources? Or is that really like he just does it all on his own?
Yeah, so whenever I'm creating a word list, I usually try to find like predefined lists online. Typically, like I'll give an example. Back in the 2020, or what is the CPTC called? Anyway, last year's CPTC, it was focused around an electric company, a hydroelectric company, and so they had they made use of dams, of course, for like hydroelectricity. Now, I thought, okay, well, if they're all about dams, then I guarantee someone's going to have some sort of password with some damn name, some damn name. So I went online. I researched. I found a whole Wikipedia page with hundreds of damn names at other places, and I made a custom script, like a whole one-line script, to just grab that website, filter it down to just the names, then put the names on their own individual lines, and then from there I have a word list of however long that is. And then from there, if you wanted to get extra fancy, you could do what's called word list mutation, where it's you take a word and then you add like different capital characters to it, you add numbers, special characters, whatever, and that significantly increases the word list size. So you can easily make a word list that's 400 words into something that's 400,000 words very fast if you do it that way, if you mutate. But yeah, that's the general process for like making your own word list. You just find some public place with information, and then you like make some guesses. That's really it.
Okay, thank you. I'm sorry,
yeah.
I didn't mean to cut you off. Thank you, I appreciate that.
Yeah, you're welcome. But as for like Cyclists or RockU, like we'll be using later, those are all, everything in there is like the most common URLs that you will find. Like there's one called robots.txt. Like pretty much every website has a robots.txt. They just hide it. So it's based off of good educated guesses. All right, back to you, Yao.
Yeah. Thank you for explaining.
Yep.
All right. So we're going to how to install Fluff. So I have this one-line command for you guys. I already installed it. I can delete it. And what you do is you take this command and you just copy and paste. I will put in a chat too. Now it should work when you type in fluff. Is everyone able to install Fluff? Okay. Does anyone need help? Next, we have Cyclists. This is a GitHub repository. You can either clone it or you can just install it on Kali. And to check, you can just list the cyclists. And it might take some time to install since the word list is pretty big. Yeah. So either or is fine. You can just do this since you're on Kali. You can just do app install cyclist. And this is how you check if you have installed cyclist. You should get the same output as mine. Yeah, it might take some time. For those that are installing, let's see. You can take a look at the repository. We'll be mostly using discovery to discover web contents. Yeah. If I scroll down, you can see the big .txt and the common .txt that I was talking about. You can see all the words. Just let me know if you guys finish installing cyclists. All right. Okay. Let's just wait a couple minutes. For those who are done, you can try to set up the Docker container by running this.
Is that different from what we did yesterday?
Yeah, that's a different container. So if you run this command, you should it should output a string, a random character. Try to get the Docker container up. Yes. Since I've already pulled the image, it should pull it for you, and then it outputs the string. So to check if the Docker is up, go to a new tab and in this URL. It should get you to this page. Did everyone see are able to see this page? Okay. Yeah, it can take a long time. We can wait a couple minutes. Interesting. Let me try to pull it again. Just can you try to do the command again to see if it works? I don't think Docker Hub is down. Does anyone also have the same error as Noah? Okay. You will run this command. Highlight it. So after you run a command, you want to go to this URL, and it should give you this page. Okay. Yeah, try to run this after. Okay. Is everyone having any problem? Yeah, I'm also not sure. Is it fine if I move on to the fuzzing techniques? You you do the apt-get update for installing Docker, since you guys already have that. Go to this URL. Okay. It should give you this page. So Noah, is it fine if I move on? Okay, so maybe yeah. Well, if you that might be a problem. So is anyone seeing the Metasploitable 2 page? Okay. That means you guys might need to get the actual IP. Since try to go to localhost, but seems like everyone's seeing the Metasploitable 2 page. So I will be using the IP. So you want to do an nmap scan and select the IP that has 80 and 8084 open. So for me, it's this IP. So if I go to this IP, it should give me the same page. So you run an nmap scan and find the IP that has the 80 and 8084 open, and you use that IP. So is anyone able to find the IP and get to this page? Okay. It's pretty much the same process as the Metasploitable. Is everyone good? Okay. So we go over the how to run the fuzzing scans. So if you want to run a basic fuzzing scans, right? So you first specify the program. We're using Fluff, and then we're using -w to specify the word list. It tells the program that what's after -w will be the word list location. And we use -u, which is URL. And then this is our target URL. And lastly, we include the keyword fuzz. This tells us where to put the words at. So it should comes after the URL. So that's that. We'll be using comment.txt. Okay. So we're using the comment.txt and then we specify the URL. In case I can just copy this. And I will put the keyword at the end. I'll paste the command. Yeah. If you run it, right, this is what you get. Does anyone get this output from the program? So anything you see here, which means you can put after the URL. So I see index and info.php. That means I can put it after the URL with a slash. So if I try info.php, it should get me to another page. This tells us the PHP version. It's on the website. We also find other things like analog. Let's see what this gives me. So it's not found. It's kind of like, do you run an mmap scan? So if you run the mmap scan, you should see port 8080 and 80. So if you find an IP that has only those two ports, you want to use that IP. So nothing with 8180 or 21 or 22. You want to look for 8080. Okay, it's all good. So here, let me run the command one more time. So you can also look at the status code, right? So 200 means okay, right? So 403 means forbidden. So let me see if I try to go to this server status. It should give me a forbidden. So we found this website, right? So we would want to fuzz this again, right? So it'll be the same process, right? I'm using the same word list, comment.txt. But instead, I'm fuzzing everything after the eShop folder. And you can see we found a lot more stuff. I'll paste the command for you guys. the IP might be different for some of you. So we can look at these things we found, right? It's an about page. I try to admin, but it says 403. Right. So this contact page, a products page. That seems interesting. So are you guys able to get this output? So we look at tool. That seems interesting. Okay, give us a message. Interesting. Okay. That means it's a redirectory. So the way this web server setup is that if you go to asset, right? Which one is? Yeah. It kind of redirects you to the 403 page, if that makes sense. See how I put .html? It redirected me to just index. So it's like a redirect, basically. Okay. So if everyone got that command working, we can go to the next command. So what we can do is we can fuzz with file types, right? And what we do is we just put .html and at the end, or .txt, right? So the same format. I'm just putting a file extension after the keyword fuzz. Okay. Clear, and you can try this, right? Try .html. You can see that there's a bunch of things. Try .txt. So with .txt, we found some extra things like to do. That doesn't show up when I just do fuzz. So if I run that, there's a to-do.txt. It might be no, it might not be the right IP. Do you have the Docker up? If you have the Docker up, it might be .3 or something. Okay. Yeah, for this to work, it requires the Docker container to be up. Yeah, so sorry about that. So we found the to-do.txt by fuzzing specifically text files on the in the eShop directory. And we found this. So this is a flag for your CTF. So remember how to get here. You also found something called to, right? To.txt. So give us something else. So if I just go to tool, right, it's different. Is anyone able to get to this page and find this flag? Okay. So we can go over the next technique. We can also fuzz. Okay, you can fuzz.txt, or you can use this command, right, with -e to fuzz everything. How do you remove it? Okay. So -e is specifying what comes after it. Right? You can specify multiple things, and it's separated by a comma. So I can run -e. You can see how it puts .php and .txt after them. Maybe also find tool and to do that .txt. Does that make sense? So to answer your question on how to remove containers, right? You do Docker PS, and you see if you see the container ID, right? You can stop it. Right? So if I stop this container, see how it no longer works. It no longer be able to load this. Right? You have to. Get the command. So does that help? Now it's back up. And it works again. Yeah, make sure you have the right IP. So is everyone good on this? With the -e. Okay. So we can go to the next, right? We know that we can fuzz files. We can also fuzz directories, right? Like folders. So from to do.txt, we can see the first line says the admin has hidden a text file in the folder, right? So it's not in eShop folder, right? So we have to fuzz which folder it's gonna be in. How do we do that, right? So we know it's inside eShop, right? And we don't know the folder name, but we know the files that we're looking for. And you see how it returns 200 here. Copy this. So are you guys able to get this output? Okay. So that means the hidden secret file is in this folder. Copy that. And this, and then we have the text file. Right. So we've got a message here. It says the PHP script is in this directory. Okay. Did anybody see this? Anyone else? Right. Sorry about
Oh, I thought you died.
my internet's kind of unstable.
Okay.
Yeah. So did everyone get how I got here? Okay. Go back. Let me check that. Sarah, you have to stop the container. If you do Docker PS, right? Stop any container that shows up here. So what you do is you Docker stop and you copy the container ID. Does that make sense? So we got this kind of hint, right? So we're gonna of course gonna fuzz this directory name. So we know that, right? We know that's a folder, and we're gonna fuzz anything that's come after it. See if I can find anything. Nothing really. There's no any 200s here. And it tells us it's a PHP script, right? So we know PHP scripts ends with .php. So if I fuzz with .php, you can see that we got a couple 200s, like 2 of them. Okay. You run Docker PS. Docker stop the container ID after this. Copy and paste that. And you press enter. So did anyone get to this point? That finds the two PHP files. Another thing that we can do with is fuzzing with filter. So how does that work? So we can do, we can just type up about anything and we can look at the filter options that they give us. Like you can filter the status code, you can filter by the lines. Oh. So are you able to pull the image? And you can filter the size and everything. So let me go back to the original, right? The first command that we run. So if we know that for to is not really useful for us because it's forbidden resource, which is filter code for the copy command. So you know how I run with extra flagger or parameter with dash fc, right? We have 403, which is forbidden. So we know 403 is like forbidden resources, which we can't like see it. That's why we filter it, right? You know how before we have these 343s for we filter it out. So if I run this command, it gives me a bunch of things, right? So one way to filter this is I see how the size is constantly changing, so it's not really useful. I can filter by the word or the lines. So I can do FW, filter word, or FL. Right. It doesn't give me anything. That command doesn't really work for the HTML since I redirect everything. So just be aware that you can use filters and we will be using filters in the next couple of slides. Let me pull up the previous commands. The .php one. Now we found a couple of PHP scripts. Right, we have CMD and email a friend. So let me go to that. I'm not sure if does the Docker pull works for you or the run. So we now PHP in def, and then we have cmd.php. And it tells us missing command. So what do we do next, right? So another thing you can fuzz is call parameter names. Right. So how PHP parameter works is that, so after you can specify a parameter name, like after a question mark, and then you put the input at the end. It's like assigning a variable. So if you're not aware, let me go to a YouTube video. Random one. You know how it has a question mark and then dash v? That's a parameter name, and this is the input, basically. This is the video ID. Right? And this is the watch page. Does that make sense for you guys, how PHP parameter works? Right, same idea. What we can do is fuzz the parameter names, right? So it might be using different variables names to run these commands. That's missing here. So I try A, maybe. Doesn't tell me anything. So that tells us we have to fuzz for it. So at this point, we are only using common.txt, but now we need to use a different word list for parameter names, right? Because we're now trying to find different web pages. Right. So this is the next word list we're going to use. It says verb parameter names. And I might need to surround the URL with quotations because we have, as you can see, this is where we use the filters, right? It will keep filter out the two words missing commands. So what I do is I filter the word. As you can see, we got an output field value. So let's try it. What does it give us? It doesn't really give us anything. So we need to run a command, right? We learn a couple of commands, right? Like who am I, right? It returns the data, the username on the system. We learn ls, right? List the directories. PWD, right? Shows current directory. So does anyone have any questions on how I find this parameter name by fuzzing it? All right, paste that in. I use the filter word too, because if you're using the wrong parameter name, it will only give you like missing commands, right? Right, missing commands. So did everyone get to this point?
So when you're saying, so on the fuzz on the left side, how it says filter response words equals 2.
Yeah.
The reason that on the internet section or when we're on the web page, we're trying to get in there, used field value, is that because that's 2 words, or whereas field with one wasn't working for you? I'm confused.
So you know how if you put like any parameter names, right? Like B maybe,
Uh-huh.
it tells us missing commands, right? It tells us that this is not the right parameter name, right? Only 2 words. But if we're gonna fuzz it, right? We're gonna filter out any 2 words output, right? From the missing commands, right? The 2 words. And then we found the right one, which is field value.
And where did we find field value at?
You run this commands, but you add this filter word too.
Gotcha.
Right? You see how it returns word 1?
Yeah, and it says field value at, okay, I see it.
Yeah,
I
so
see
it's
it.
different. It's not missing commands anymore. So we know that's the correct one. Did anybody have any problem on this? Let's take a break for a couple minutes. So did anyone have any questions on any other slides? For the E1, it's for fuzzing file types. So you put an extension like .html and then you follow by a comma to separate the file types. One after is fuzzing directory names. Before we're fuzzing file names, right? Now we're fuzzing directory. And the command for that is this one. And we got the file name from the to-do.txt. So far we have fuzz files, directory names, and filters. And we just done fuzzing parameter names. So the next part is that we can also fuzz parameter values, right? What's the input? Fuzzing the input. So kind of the same idea. We just put the fuzz keyword in the input. So remember the other PHP files that we found besides CMD is this. Email a friend. Right? So this is different, right? So it already provides us the parameter value. So the name, I mean. And we can try 1, right? It says cannot find any email by that ID. You can try 2, but I'm not gonna manually like input the numbers, right? There's a word list for that. And it's not in discovery and web contents, it's in fuzzing. So you can see there are 3 digits, and there's also a couple of word lists for numbers. I'm gonna try the 3-digit one. And I'm gonna copy my URL. And I put the fuzz word at the end. I think you guessed it, we also need to filter this down, right? So we're gonna filter by the word, I guess. See if that gives us anything. So it does give output, right? With different words. So copy this command. So everyone understand why I want to filter the 7 words, right? Which is cannot find an email by that ID. So if we look 6711. Found some emails. Last we have 739. So this is your another flag that you can use in your CTF. That's that. Does anyone have any question on how I got to here? On how I fuzz it? Yeah. URL part. Specifically this PHP. Email a friend.php. So if we go to this .php file, right, it says missing value in the email ID. PHP, I don't know the complete one. It's a programming language. It's a general purpose scripting language for web development. It's used for backend and sometimes front end as well. Right. Same thing as .cpp and so we know that it's running some kind of code behind this file, right? So it tells us the parameter name, right? So we don't have to fuzz that anymore. Right. I put something in there. So let's say I put 1, right? So it gave me that cannot find any email by that ID, right? So this is the wrong ID. And I can either manually like type in numbers in here, or I can just simply fuzz it, right? So there's a word list for numbers, right? So if you go to this directory, fuzzing, and then it says 3 digits from 0 to 999. And we can use that to put the numbers after the parameter name. And that's what I did. Right. So this is the complete URL, right, with the fuzz keyword. So it will put like 0, 1, 2, 3, 4, all the way to 999 in here. Right. So what happens if I run that? You see how it got a bunch of outputs, right? So they need to be filtered, right? They all return 200 because it gives you an output. This PHP file gives you an output. And this word 7 means that it's this 7 word, right? It tells us that we cannot find the email by the ID, so we need to filter that. What we're looking for is something that's other than that 7 word. When we do that, we get 3 numbers, right? We have 11, 67. If I try 11, right? It's something else than the cannot find this email by the ID, right? It's an email. Does that make sense? Okay. So we went over like how to fuzz this, right? The parameter name, the parameter value, right? File type, file names, right? And then we have also fuzz the folders. Right? So recap. So now it's your turn, right? There's a CTF on the port 8080, right? Right. You see a different page on 8080. If you put colon and then 8080, you should see this page. Does anyone get to this? Okay. So I'm pretty sure you know where to go next, right? Fuzz it with common.txt, right? This is always your starting point, right? So you guys can run that. That's for the CTF. Right? And there's flags. This is the format. So you find something that surrounds with curly brackets. Make sure to submit that, specifying the number. And there's 10 of them on the port 8080. So yeah. So do you guys have any questions on web fuzzing? Now that concludes my workshop on web fuzzing. I hope you guys find something useful from this.
Thank you, Yao. All right. So it is now roughly 11:30. I assume everyone would like a break. So how about we take a break all the way up until 12:10? That'll be our lunch break. Does that sound good with everyone? All right. Okay. Then meet back at 12:10, and we will continue with our brute forcing workshop. Yeah, tongue twister. All right, see you then. Welcome back, everyone. Right now, we're going to go into the password cracking and brute forcing workshop. Let me share my screen real quick, and we'll get started. All right. Starting off, what exactly is password cracking and brute forcing? In very simple terms, it's simply trying all possibilities for a given password or a hash that we're trying to crack. We're trying to permute everything, and there is the problem with brute forcing cracking a service where it's very noisy. What we mean by this is, let's say there's an SSH service running for you to access a computer remotely. If you try to brute force that service, you'll be generating a lot of requests, and that raises a red flag for systems. And when that happens, a system typically knows, okay, we're being brute forced. And then in a real life scenario, a system will automatically block your IP, preventing you from doing any more sort of brute forcing. All right. Some of the tools that you'll see when talking about cracking or brute forcing are John the Ripper and Hashcat for cracking. And then for brute forcing, you will have Hydra and crackmap exec. All of these are useful in their own ways, and I have my own preferences for what I like to use. You may have your own, but I'm going to be presenting on all of them, giving a basic overview. They all, like John the Ripper, Hashcat, those two are interchangeable. Same thing with Hydra and crackmap exec. The reason why we have multiple tools is because sometimes one does something else that the other does not. So for example, John the Ripper, JTR, it only cracks hashes, whereas Hashcat can crack hashes and also help you generate password lists. And then with Hydra and crackmap, I'm going to refer to crackmap as CME from here on out. Okay, so crackmap exec, CME. Hydra can attack a whole range of different services and even web pages. It can attack a lot of things. It can do a lot of brute forcing, and it can do across multiple networks, multiple IPs, that sort of thing. Now, CME can only really crack a limited range of services, so like SSH, SMB, WinRM, etc. And CME is primarily used for like Windows enumeration. All right. Now, some of the word lists we use when doing cracking or brute forcing are rocku.txt and then also Cyclists. So rocku, we can go ahead and execute this on our machine. Put this somewhere that you know it'll stay safe. I like to put all my word lists, every tool that I download, into the /opt directory on Linux. That way I can just quickly access it. I don't have to go through user bin or wherever. So this is probably the more famous word list that exists out there. It is a huge word list, I think, with over 14 million passwords in it. And it's just the most common passwords you can find out there. I remember one time I was doing a CTF on TryHackMe, and I could not figure out how to get in. So I just set up a simple brute forcer on a username I found, a single username that I found, and I ended up getting in before anyone else. And the funny thing is that was not the intended way in. And the password was Winnie the Pooh. Kind of funny to think that Winnie the Pooh is in rocku.txt, and that's a common password. All right, and then in the previous workshop done by Yao, you saw Cyclists. So all of you should already have this and should know where it's located. Let me post this command in the chat real quick, and let me share the slides. I think that'll be useful for everyone. That's the command to get rocku. And there are the slides. How would we add it to a certain directory? Well, what you can do is change the directory that you are currently in and run this command right here. So that would just be cd/opt. Or what you can do instead is simply grab this and then move rocky.txt into the opt directory. So one option is cd/opt like that, changes your directory, or you simply do the wget and then, you're going to, after that, do move rocky.txt into /opt. All right, moving on. We will be using a Docker container for the CTF, and Noah, I'm sorry, your PTSD is probably going off right now since your Docker container is not working. But yeah, we're going to be using a Docker container that has SMB and SSH on it. It's just like we did before with Docker run, but of course this is a very large command compared to last time's workshop. Let me put this again in the chat. That will set up the entire Docker container for you. And the ports you should see for that, if you nmap, are 22, 139, and 445. Also, before we get started, I created some sample passwords that we can crack. Just gonna put those into the chat real quick. Okay, let me zip them instead. Okay, that work. Okay, I'm gonna put the example passwords on Discord. I hope all of you have Discord. I will put it into Winter Workshop. Let's see. Nope, that's not the right one. There we go. So these passwords, those will be used for our example today, okay? And if anyone has trouble accessing those, just let me know. Now let's get into the fun part. So cracking with John the Ripper. Are we supposed to get an error when trying to run the command? Which command? The Docker one. No, you're not supposed to be getting an error. Is everyone getting an error? Here, let me show my screen here. Where did I run? Let me close this out. So I'm stopping the previous Docker container from Yao's workshop, the Fuzz workshop. All right. So this is the command that we're going to copy and paste in. Well, you always have to put sudo first if you're not already root. In this case, say we have sudo, and then it'll run. Should I do that too? Get out of the other Docker? Yeah, you should definitely close out the other Docker container. Yeah, if you close the terminal, then I think it should be fine. You can confirm that again by doing docker ps. And yes, just like Tyler said, if you forget sudo, you can do sudo bang bang or sudo exclamation exclamation. That'll execute the previous command that you tried with sudo. Okay, so is this working for everyone? And by the way, it will hang like this. You won't be able to execute any sort of commands inside of this container. The reason being, this is a workshop one, and there are flags hidden within this. And if you really wanted to, you could just use root privileges to get all the flags immediately. We don't want to do that. Or, who am I? See, it won't do anything. It's just a Docker container. All right. If we nmap that container or nmap our network, we see it's open. We see our port 22, 139, and 445. Is everyone at this point? Anyone need any help? All right, if there's anyone that needs any help, just let me know, put it in the chat. And also, please do download those password files. We will be using those. Yes, if you can download them. I have the drag and drop feature enabled. If you don't have the drag and drop feature enabled, I can just give you guys these hashes. You know, let's just do that. Yeah, that's easier. So put this a.txt. That's the hash. A.txt is that one. I am very efficient, guys. A.txt. D.txt, and then the last one, which you can name whatever you want. I'll name this id.txt because it's ID RSA. I cannot paste this in. It's too large. Yeah, if you create a shared folder with your VM, you can definitely do that. Since I cannot import the ID RSA, I'm just going to take you guys through how to make an SSH key. That'll be useful for you guys, guaranteed. Okay. Back to John the Ripper. All right, John the Ripper, password cracking tool. It cracks hashes and it cracks encrypted passwords. Now, there's a difference between a hash and an encrypted password. A hash is non-reversible. It's a one-way thing. That's like the main difference between a hash and a password. Hash one way can only be turned into a hash. Something can only be turned into it once. An encrypted password is encrypted. A key is generated, and then that key is used to decrypt it back into its plain text. So it's reversible. That is like the biggest difference between a hash and a password. And that's something to keep in mind. Now, what does that actually mean? It means you really can't figure out what a hash is. The way cracking hashes works is you're guessing. Let's say you have a word, let's just say it's hello, and you hash it with a specific hashing algorithm. No matter what you do, if you keep it the same case, let's just say all lowercase, if you rehash the same hash over and over again, hashing type over and over again, you'll get the same output. So the way this works then is you have your word list, and whenever you put it into like John the Ripper or something else, it simply turns it into that specific hash and then compares. And if it's the same, then it tells you, okay, well, that's the password. And there's fancier password lists called rainbow tables for this purpose too. It's just passwords that have been hashed in a specific hash so then you can compare and see. It's like a game of memory, but worse. And then encrypted password files, that is also a thing. That's what the IDRSA is. That's what I was going to show you with the larger example. So you can have a password file that's password protected. So it's the password. It's a little confusing, but we can still crack both. All right, how to use John. Very simple, very basic. It's just John and then the file that is containing the hash. Now, when you do this, John the Ripper will use its default word list, which is not necessarily the best. If you want to specify your own word list, like rocky.txt, that's what we're going to be using, then we have to use the -- word list format. Where's an example of that? Right here. So it's -- word list file. In an example, we could do John, and if we know the format, we could say raw MD5, which is a type of hashing algorithm. Word list, Rocky equals rocky.txt, space, and then let's just say a.txt. Now, format is the format of the hash, and we'll get into how to identify hashes real soon, but these are just examples. Again, you know the format, -- format, hash type, password with hash. John will typically automatically detect what the hash is, but sometimes it has trouble. Okay, let's go ahead and do an example. I have my password files here, A, B, C, D, and cat A. I don't know what that is. Okay, I can't identify hashes based off of what I see, except one. That'd be base 64. That one's easy. This one, I don't know. How do we identify this? There's a very special tool called hash ID, which everyone should have. And all you do is you do hash ID, password file, and it tells you, okay, these are the potential hash types. So we see there's bcrypt, burning board, whatever that is, and blowfish. So these are the potential types that we can possibly use. And we can do that for any of the other files too. So hash ID, b.txt, hash ID c, unknown hash, b.txt. All right. Very straightforward, very easy to use. This is useful for John the Ripper and Hashcat. All right, now into an actual brute or cracking example. Again, we're going to use a.txt right here. So we're going to type John, and we're going to use our word list rocky.txt. All right, this doesn't autocomplete. Rocky.txt and a.txt. Right, I already cracked this password. What John does, if you've cracked a password already, it saves it in its database. Let me see how to show that real quick. But for you guys, it should show a cracking process. Does everyone see an actual cracking process going on when you did that command? Yes, okay. All right, Austin says yes. Sebastian is asking, how do we find what directory we have rocku or word list in? If you did the command that I sent earlier, rocku is located inside the directory that you were in before. So if you did a git clone inside your home directory or tilde, then it would be there. I said earlier, I store all my passwords, all my password hashes or scripts, tools, whatever in /opt. If you can't find it, you can do locate rocku.txt, and that'll find it within your path variable. So you see, I have different versions of this. Okay. Elizabeth is asking, do we put the actual hash for a.txt if we don't have it in a file? Yes, you need to put the hash into a file. It won't work from standard input. So you can't just do John and then hash whatever. You can't do that. It's not the way it works. Should I move my a.txt, a.txt into the tilde directory? If you want to, yes. Tilde, again, is the home directory for your user. For root is /root. Let me turn off Discord. I don't know if you guys can hear that noise. It's annoying. Oh, someone needs help through there. Oh, it's okay, yeah. Okay, I think that's Noah that's contacting me. I will take care of you later, okay? Oh wait, it almost looks like you're not connected to a NAT network. It's really weird. Or not NAT network, just NAT. Okay, but anyways, I'm gonna close out Discord. Okay. Yeah, you can move the files wherever you want. I just have a preference. You could have honestly put all these files in the same directory and you would have been fine. So let's say you put it, I don't know, you were in the temp directory. All right, and then you did the git rocku here, the script that I sent earlier, and then you put your password files here. So a, b, c, txt. You can execute it all through there. I just have a certain organization that I like to keep. Okay. Does this make sense to everyone? In simple cracking. Let's go ahead and try it with b.txt. Oops. All right, we're gonna try b.txt. And again, this is already stored inside of my my database. We'll talk about how to. Yeah, I'll get it later. But you should have seen that. I think the first password was like password or like password 1. Is that right? Or awesome. Yeah, there's awesome. I think one of them is password. I really want to show this all working. I don't like that it's not showing you guys. B.txt was bang bang. Okay. Now go ahead and try c.txt and then d.txt. See what you get. Okay, did anyone figure out c.txt? Austin, you are correct. Oh, this right here is a hashtag called base64. And we can know this because base64 has this notorious equals sign at the end of it. So this, if you ever seen equals at the end of a hash, it usually indicates that it's base64. Now there's not always two, there could be either 1, 2, or 3. It just depends on the length of the original password. But we can decode this. Everyone has an executable in their Kali called base64. So we can do the decode flag -d and c.txt. And from there we get more stuff. Output this into another file called c.txt2, or sorry, c2.txt. And from there we could do hash ID and find, okay, what is this? All right, so go ahead and crack that. What does hash ID do? It identifies what kind of hash is inside, or what kind of hash the file is. So if there's different hashing methods. So if we do a hash ID on A, we see we get 3 possibilities of blowfish, woltlab, and bcrypt. And then if we did it on b.txt, that tells us this is potentially SHA-1, double SHA-1, etc. So it narrows down what kind of cracking needs to be done. So every hashing algorithm is different. Still on A, can't get it to run. What exactly is going on?
I don't think I'm in my home for the root directory, not the root directory. It says Kali.
Okay.
And it's got the, I'm not sure, I think you called it a tilde. So I moved all my A through D files in there. I have the rocku.txt, but I'm not exactly sure what commands I'm running here. I'm typing in John -- word list, and then I'm not sure what should come after that. Just
yeah, okay. So you do dash John, in your case it'd be John -- word list equals, since it's in the same directory that you are in, you just type in rocky.txt and a.txt afterwards.
okay, let me give that a shot. Thank you.
Yep, you're welcome. And let me know if that works, okay? All right, but everyone else got A, at least A? Is there anyone else who did not?
I get it. I got it. Thank you. It
Okay.
worked. Thank you.
All right, awesome. All right, I'm going to assume everyone else got through A, B, C, D examples here. Now, I'm gonna go back to the presentation. I know Sebastian, you got to catch up, but I think it should be straightforward what's going on.
I got it. No worries.
Okay.
Thank you.
Yep, no problem. Okay, let's move on. These are just more examples that you can use as reference point. So the first hash that we had was crypt. So we originally just let John figure it out for itself, but we could have put -- format equals crypt, and it still would have decoded and given us the correct password of awesome. Now, what about the case of password protected password files? How are we supposed to deal with those? Because you really can't just put a password file and crack it. That would be the opposite of what you want. Like, that doesn't address the password that is protecting that password file. So what I mean is, if we go to our system, now, I do want everyone to do this right now. We're going to generate a SSH key for everyone. We're going to SSH-keygen. All right. On this first prompt right here, go ahead and click enter. And then I'll say a passphrase. Let's just type in password. You won't be able to see it. Just type in password, all lowercase, and it'll generate a password file. Mine right here. So in your home directory, go to home directory by doing that, cd tilde. You have a directory in there called .sh. If you list everything in there, you'll see the password file that we just generated. So IDRSA. I'm going to guess some of you didn't get what I did for this whole process. So let me remove all this. Let me show you again. SSH keygen, enter, push enter once, put in the password of password again. There you go. And you'll have this IDRSA file inside of your hidden SSH file. Now, if you don't know what SSH keys are, we can explain that at some other time. But what we've essentially done right now is generated a password file and password protected it. And our password for that is, well, as we typed in, password. So we can crack this. What we can do, I don't have that known host file. Is that okay? Yes, that is completely fine. You only need the IDRSA and then the public key. Yep. All right. So now we can crack this. We can, or no, let's just say we tried to log into somewhere. It would ask us for a password for that person. So as an example, let's just say we SSH in as Yara on our Docker container. That's a user that's on there. And we pass in with -- the IDRSA file. It would ask for a password, and we don't know the password. Click. All right, what we can do is use a script called SSH to John. Now, this is, we just do locate SSH to John. We find it's there. User share John, SSH to John.py. If we run this on the IDRSA, now let's just say we output it to j.txt. We get j.txt. Now what we can do is do John word list rocky.txt. Word list equals rocky.txt, and then run a crack against this. No such file directory. Oh, I don't even have Rocky. Oops. Let me get that real quick. Is that command? And whatever. All right, cool. In our SSH folder, we have our j.txt. Now, again, if we do John Rocku j.txt. We should be able to crack it. Sometimes this can take a while. It all depends on how complex the password is. A password should not take long. I don't know why this one's taking long. Okay, but eventually this will crack and tell us that the password to this IDRSA file is password. Stuff. Now we can also take this j.txt that was generated from IDRSA into hashcat if we wanted to. Actually, let me check myself real quick. Let's just see if that's actually true. You don't have to follow me right here. Doesn't seem like it. Okay. Yep. Ignore what I said about hashcat. All right, let's see if this eventually cracks. I may have mistyped password. If any of you get it, let me know. All right, so I got through this. Let's skip ahead here. Yeah, so we just went over this. You can do Python ssh to john.py. And then the SSH file, IDRSA. And then we do John -- wordless rocky.txt, and then the hash file. Were we supposed to put a passphrase? Yes, you were supposed to put a passphrase. Yeah, I guess let me go through that one more time. Stop this. I'm going to remove my IDRSA files. j.txt, SSH -keygen. We push enter right here, and then we enter a passphrase. I'm going to enter in PASSWORD and enter it again. There we go. And we have this IDRSA file. And then we do will work from here? No, it won't. We locate SSH to John. We see it's there. Copy that whole directory. If we leave it like this, we'll see this ginormous wall of text, which I don't want to read. You just put that into j.txt, and then j.txt is what we're trying to crack. So John word list equals rocku j.txt. All right, I'm gonna move on here. Yeah, here's an example. Again, Python SSH to John, it's IDRSA, and then put that into some file, and then we use a word list rocku to crack it. It may take a while, just because cracking takes a lot of resources. And this is an alternate use for your GPU, by the way. So if you have a beefy GPU, you can crack hashes for days. Not even kidding. You know those fancy video games you play? Nah, just crack hashes, crack passwords. If you want to move j.txt, yeah. Again, it all depends on you. Whenever you're executing a command in Linux, you can specify wherever the file is. You don't have to have them all in the same directory. Can I go over that? Okay.
Yeah, so like I'm on my SSH file right now, and I can see the, the public key, the private key, and then I have the J text that we made because I did the John to, or the SSH to John. I did that portion. Now, if I want to run the RockU command and all that within this SSH file, that's the part I'm at right now.
Okay. So let's just say I'm just in my home directory and I need to access my ID RSA. I'm only here. I don't have that. I don't see it, but I know where it is. It's located in that hidden SSH file. What I can still do, again, is run SSH to John. So this points, this executes SSH to John. It accesses through this entire directory structure just to execute SSH to John. And then we're going to specify that ID RSA file that is located in .ssh in our home directory. ID RSA. And I'm going to pipe that into a new file. This time I'm going to call it j.hash to keep them separate. So now, still in the home directory, j.hash is now here. And we could do John, wordless, and let's say for your case, RockU is in your home directory. You can just specify RockU.txt. Since whenever you're executing anything, Linux assumes you are running everything in the directory that you are currently located at. But since RockU, in my case, is located elsewhere, I have to specify where it is, which is in my /opt directory. And from there, we have our j.hash file in our local directory. Well, let's say, again, we have j.txt in .ssh. We can still access that from our home directory, which is .ssh and j.txt, and this would still work.
I got you. Okay, so it's just a file directory, just pointing it to the right location. Got you. That makes sense. Because I just did it the same. I just did it outside of the SSH folder and just did it back in the home directory, and it did crack the password right away. Okay, got you. Thank you.
Yep, you're welcome. Okay. Now we're going to move on to Hashcat. We're not going to go too deep into Hashcat. It's harder to use, but it is my preference for cracking hashes just because I can gain more control over how the hash is being cracked. For now, for the workshop for the CTF, you can choose whichever you want, but for beginners like everyone here, or for almost everyone here, I would highly recommend you just stick with John the Ripper. Okay, Hashcat, again, similar to John, but I think it's better. You have more control, and it has the additional functionality of being able to generate password files and mutate those password files through its rule sets. We're not going to go into that. That's just an alternate use for you guys to know. But how to use Hashcat, it's definitely more difficult than John. You have to actually specify the hash ID itself. Now, what is the hash ID? Hash ID is very specific to Hashcat. You have to know what the ID is for Hashcat to crack your password. And then Hashcat also has no default wordless, so you have to specify it. And you must also have your hash that you're cracking inside of a file. So I'm going to give an example. Again, this is just for your knowledge. This is not, if you know John, you'll be fine for the workshop, but I'm going to go a little faster through Hashcat. So we have Hashcat, right? We see that works. Now we have, again, our a.txt. We have that, and we do hash ID on our a.txt, and we still see is that, okay, it's bcrypt or blowfish. So what we can do is take this information and go into Hashcat try to find what the ID of bcrypt or blowfish is in the hashcat database. Okay. So we can do dash dash example hashes. And if we did just that, it would dump everything. We don't want that. We want to be able to read. I'm just going to grep for bcrypt, since that was one of the options. And I see, okay, bcrypt blowfish. That sounds pretty much exactly what I want, but what's the ID? This is where some grep magic comes in. I type in -v3 and I'm able to see 3 lines behind where this came from. Grep is a tool to grab a specific information from a file. So in this case, let's say, okay, I'll just go with what I'm doing right here. We have this giant wall of text from doing just hashcat example hashes, right? That's a lot of information for us to process. Well, what we did here is we put that output, we piped it. That's what this is, pipe. We put the output from here and placed it into grep. So we're saying, okay, out of this wall of text that is blinding, I want to grep or grab any line that has the phrase bcrypt within it. Okay. Does that make sense?
Yeah, that makes sense. And then the -b3, is that just like another flag that you're looking to specify more of what exactly you're looking for?
B3 means we're going to look within the previous 3 lines from where this was grabbed. So let's say we did instead B1.
Oh,
we
would get previous. Gotcha.
Yeah, I mean B1 still works. So it's like looking up and down 1, and then if we did 3, we get 1, 2, 3 from where bcrypt is 1, 2, and then 3.
Ah, got you. Okay, thank you.
Yep. That's what B3 does, and there's also A3, which is like after 3. So that's the way I like to think of it. You can use either or, it gets you the same result. All right, but now in our example here with bcrypt, we have the mode, the ID 3200. So then we can go into hashcat, mode 3200, and then our hash, our file with the hash, and we do our password file. So hashcat, the mode ID, the password file, or the hash that we want to crack, and then our word list. Well, I already cracked this in hashcat, and it tells me, okay, I can see the crack by doing --show, and then we see here this was our original hash. And then at the end we have the password of awesome. All right. I think. Okay, so yeah, we can actually automatically find the ID, this right here, 3200 with hash ID, if we just specify -m. So we do if we did that in the beginning, a.txt, it would tell us blowfish, bcrypt, those are mode 3200. All right, and you can do this again for any of your hashes. I'm just so used to doing it manually that I forgot about hash ID. All right. Again, we went over hash ID, and went over this example of trying to find the hash ID ourselves manually. You can use whichever you prefer. And we just did this, mode 3200 or hash or a.txt with rocku. And that basically concludes hashcat. Is my screen messed up for you guys? It's really weird. Hold on. All right, now brute forcing. I know we spent a long time on hashing, cracking hashes, but brute forcing, I guarantee, will be much faster. All right, it's essentially the same process, but with different tools, and you're targeting services instead of files. All right, we're gonna be using Hydra in our first example. Hydra again is the big bad brute forcer out of all brute forces, in my opinion. Okay, it can crack. Okay, sorry, it can brute force tons of services, and it's very flexible. Problem is, it can overwhelm a system very fast. It can overwhelm your system very fast if you don't have the proper number of resources. But it's overall a very good program to use. All right, I'm going to go through these examples first, and then we'll go ahead and try it for ourselves. And this is where we're going to be using the Docker container. So to use Hydra, here is an example. We have Hydra-L user-p password, the tries, the number of tries we're going to do, or threads. So this right here, -t, is probably the most important flag you can remember. I'm not even kidding. This, you need to remember -t. If you don't limit Hydra, you will destroy your own computer. Sometimes the way Hydra works, if you don't put -t, Hydra will actually trip over itself, and then it give you thousands of false positives. So it'll just start to say every password is valid. So you need to put -t to not trip. All right, then the IP and the service we're targeting. Let's say it's SSH. So the user you want to log in as, the password for the user, number of tasks or threads, target IP address, and then service such as SSH, SMB, FTP, RPC, MySQL, whatever. For exactly what services Hydra can crack, that you would have to look that up yourself, but it can brute force a bunch. All right, here's another example. Now let's say we had a list of users and a list of passwords. We can use those too. So we can do Hydra-L user list -P for a password list, and then everything else stays the same. So this, of course, would take far longer because you have two whole lists to iterate through. Oops. Okay. Does that make sense to everyone? -L, lowercase l, for a single user you want to log in as. -L for a user for a list. Then lowercase b and capital P for almost the same case as user. All right. Here are some useful Hydra flags in, let's say, a competition. I use these in CPTC when we have an entire network to brute force. So let's say we have 10 computers that need to be brute force. Well, I can just set up a single Hydra command to then say, okay, I have my list of users, I have my list of passwords, and I have the IPs. So I do -m, and then the servers, the IP addresses that I want to brute force. And because the output of this is going to be so large, I don't want to deal with that. I only want to see the valid ones. So I do -o, and then the name of a file that I want it to output into. So -o for output, valid. And let's also say that in a good setup, in a good defensive setup, a service will have a certain amount of time and it has to wait before you can enter a new password. Let's say it's like 3 seconds. You can only enter a password every 3 seconds. That is a way to deter brute forcing attacks. And to get around that, you can do -w for wait time, right, to wait a certain number of seconds between the responses or the requests that you make. So that's a way to get around it. And then -v or capital V is verbose mode. -u loops or U loops through users instead of passwords. What I mean by this is in this example right here, if you have a user list of 10 users and you have a password list of 1,000 passwords, it will go, okay, user one, we'll test you first, user one, and passwords 1 through 1,000. And then I'll move on to password 2, 1 through 1,000. With the -u option, it will reverse that process and say, okay, password 1, we're gonna test you against user 1 through 10. So it's just reversing. All right, and then -4 or -6 is used for IPv4, which is default, or IPv6. You don't need to worry about that right now. Everyone uses -4, or everyone uses IPv4. And here's some of those advanced Hydra examples. So you have a user list, a password list, an output file with 6 threads, and then we're attacking a list of IP addresses on SSH. Now here's probably the most advanced use of Hydra. You will not need to know this. You do not need to remember this. This is just an example. What you see right here is a web request. So if you remember back during the fuzzing workshop, Yao showed us a web request with a get request. Now, a get request gets a site, but there's also a post request, which means you're pushing or posting to the site. If we intercept this post request on a login page, we could potentially see the username and password that we are sending. So in this example right here, we're making a post request to this page on this host right below. Okay, and then we have our username of OTW, and then we set a password of OTW. That's what we see right now. Hydra can then brute force based off of this information and brute force this site. So we have our same thing here, username list, a password list, the IP that it's located at, and then we're going to do an HTTP post form because this is a post request right here. And we specify, based from this IP address, the login page that it's located, that URL. All right, this is our username. So we're saying a user is equal to the user variable. This is default inside of Hydra. And our password, this is following the same format as down here. And password is equal to the password variable in Hydra. Following the information we have right here, we do an and sign, login equals login. And this right here, login failed, that is the output if the page fails to log in. That tells us, okay, this is the error we get if login has failed. The page says login failed. Again, you don't need to remember this right now. This is a more advanced use, and it's using another program that we have not taught yet called Burp Suite. That's just to show you an example. All right, these are the problems I mentioned earlier. Does not necessarily show you what's going on. If used improperly, it can give you false positives, and it requires a good amount of resources to actually run. And in the case of false positives, that's where I said it's tripping over itself and giving you those false positives. That's why you need -T. Okay, let's do a quick example. So we have our Docker container. Where'd I go? There am I. Okay, we have our Docker. This is our network. I'm just going to nmap it real quick. Okay, and I see my IP address. This one right here. So we have port 22, 139, and 445. For this Docker container, ports 22 and 445 are both brute forceable. 139, you can completely ignore it. Same thing for the CTF, like you just ignore 139. All right, now let's say I have a user, or let's just do Hydra. We have a user called admin, and say we have a password, or we want to specify a password file, and we're going to use RawQ. Okay, then we have our tries. I'm going to limit mine to 4. Then we have our IP address, and we're going to brute force on SSH. So if you let that run, it'll do its thing and it won't show you anything. This is that problem I was telling you guys earlier, where it won't, you don't actually know if it's working unless you do verbose mode. But if you do verbose, you get a wall of text and it blinds you. So if the admin user is there and Hydra finds a correct password, it will output that for you. But we don't know any of the users on this, right? We don't know anything. How are we supposed to know what users exist on that Docker container? Well, this is where I'm going to show you guys crack map exec. This crack map, or CME, can be used as a brute forcer, but also as an enumeration tool for ports 139 and 445. I'm just going to skip down. We'll come back to this later. Okay. Damn, I thought I'd provide a better example than this. Okay. I'm just going to show you on my screen if that's okay. We have crack map exec, and it can only be used to enumerate what's called shares on SMB. SMB, our IP address, we're going to pass in no user, no passwords, and we're going to grab the shares that are available. Well, SMB is a file sharing system. Usually it's known to be mostly in Windows. However, there's also a Linux version that we are using right now. And all we're doing here is we are sending in a user, like no user, no password, just a blank user, and we're trying to find the files that we can see. And this is on Docker container. We find, okay, we have anonymous, we have these shares, anonymous, anime lover, lapis lazuli, Danny, HR, and temp. And then our permissions on this, we only have read and write on anonymous, and that's the share. But what we can intuit from all this is that anime lover, lapis, and Danny, those are users on the system. Those look like usernames to me. Let's go ahead and try this. Let's say I should have added another share. That's okay. Let's say we wanted to brute force anime lover with Hydra. With Hydra, our command from earlier, anime lover. And we're going to brute force him on SMB. Or no, let's just keep it SSH, it's fine. And it'll give you a warning that you had already started Hydra and it didn't stop. So it's going to stop your previous process and start a new one. So now it's running and it's going to go ahead and try to break into anime lover. Now I know I didn't really go over CME, so let's go ahead and do that. Sorry if this is a little all over the place. All right, I already mentioned all this. Using CME. So basic use of CME is crack map exec. The service that we are targeting, in our case, it's either going to be SSH or SMB. Target IP address. And the user list, username, or a user list, it's by default U. So if you had a list, you can just do dash lowercase u list, and same thing with dash p. Quick note about crack map, it has to be in this format. There's no getting around it. You have to put CME, then the service name, and then the IP. You cannot switch up IP to be right here and servers to be somewhere else. It's very picky. The program is very picky, and it made me frustrated sometimes. So as an example, we have CME, SMB, our target IP, and we're going to try to log in as admin. Another example, username admin, password list of plist, a username list, and then a single password of admin, and then we can do a double list. And this is what we did just now, where we're trying to log in. If we had a login credential, we would do the username, password, the shares, and because we are on a local host, because Docker is running on your local host, you'll do -- local auth. This is a hint for if you have trouble with logging into SMB or SSH when trying to use CrackMap exec. All right, let's go back to here. So we see by running our Hydra right here on SSH, trying to crack Anime Lover, we got the login as Anime Lover and its password is Naruto. So if we try this, I'm going to show you how to log in as him on CrackMap exec. So let's go ahead and try to log in as him. Anime Lover, password Naruto. I think this is where local auth comes in. Local auth. Something's not right here. All right, I apologize for this. I don't know what happened. But we're supposed to see the Anime Lover now has access to his file share that's right here. He's supposed to have read and write permissions to it. Let me. Okay, but do you guys understand what's going on here? What we just did? Anyone need me to go back over something? Yeah, I know I can try SMB client. I do need to show everyone that because that is part of the CTF. I think I stuffed too much into my Docker container. It's gonna be a little difficult for everyone. So like Austin just said, because CrackMap is not working, we could try a different tool called SMB client. That's a tool I use all the time. The SMB client, our user as Anime Lover, and then IP address with these slashes. These are essential. Well, we are specifying an SMB share. So we're specifying, okay, we're going to want to connect it over SMB to Anime Lover. This is the share right here, this one. You need these slashes. Don't ever forget these. So login, password, Naruto. Really wondering what's happening here. Try different one. Okay, something's going on with SMB. I'm gonna have to try to figure that out. But if this were working, you would be able to log in as Anime Lover on SMB and be able to see his shares. This is also why I provided a little bit of redundancy. We can try to log in as Anime Lover over SSH. We do that, type in his password. You see if we get in. Where am I? Anime Lover, present working directory, his directory. And this is where the share would be. See, I'm somewhat smart by providing redundancy because I knew something would go wrong. All right, so now we have a flag which you can submit on the CTF and then an IDRSA file. I wonder. Yeah, now we can see different users that are on the system, and we can try to attempt to crack each of their passwords. And that's where the CTF comes in. I think there's almost a question for every single person on here. One thing to note, not every user here is on SMB. Some of them can only connect through SSH. So something to keep in mind as you're doing the CTF. Live demos never go right. Yeah, they never do. But I'm gonna need to fix this Docker container for you guys to access SMB, because there are some questions concerning these shares. Like there's stuff in HR, there's stuff in temp, but I bet you guys can figure out where temp is. But yeah, that's pretty much the end of brute forcing. Does anyone have any questions about Hydra or crack map exec? I don't remember its password. When will this lesson be up? You mean the YouTube video? It will be up as soon as I can. Okay. Yesterday's workshop is up. It's on the YouTube channel, so you can go ahead and look through that. This one, again, I'll try to get it up as fast as I can. Problem is, again, I'm leaving shortly after this workshop ends, so this one, tomorrow's, and Monday's will all probably be delayed.
Okay. Yeah, no worries. Just had a bunch of issues with the dang Docker. Finally got it working, so
nice.
Catching up.
Awesome. Glad to hear that. Okay. Any other questions? All right, if not, then this concludes today's workshops. The rest of the time will be dedicated to the CTF and answering any other questions that you guys have with that. I'm going to upload my CTF questions for brute forcing and cracking, so keep an eye out for that. Hopefully they'll give you a little bit of a challenge, especially since the Docker container is not working. I'll try to fix that in the meantime. Otherwise, you're all free to go or stick around and do the CTF and ask questions. Okay. Yeah, and thank you for coming to the workshop. All right, yeah, thank you.